Hello and welcome to this tutorial. So in this tutorial, we are going to answer a question on energetics of reactions. Energetics of reactions. And this is an extract from 2017. 2017. This is a paper. So the first question requires us to write a balanced chemical equation for the complete combustion. So obviously, if you understand combustion, we have two types of combustion. There's complete and incomplete. So complete combustion produces, so if your combustion is complete, it produces carbon dioxide and water. If your combustion is incomplete, then it produces carbon monoxide and water. So the first one is going to be CH4 plus O2 to produce CO2 plus H2O. Because it's a complete combustion, then we have to balance the equation by putting a 2 here and putting a 2 there. It's a balanced chemical equation. Why should methane never be burnt in limited oxygen, in limited air? So when it's burnt in limited air, it's going to produce, so it produces a poisonous gas, which is carbon monoxide, which leads to respiratory related diseases or suffocation. So it's a poisonous gas which combines with hemoglobin and forms what we call a carboxyhemoglobin, which obviously leads to suffocation as there will be limited oxygen. Then B1. So methane is used as a fuel in industry. So using the bond energies given in the table, we're asked to calculate the enthalpy of combustion. So here when we break it down to calculate the enthalpy, which is the enthalpy of reactants plus the enthalpy of products, we're going to look at the enthalpy of reactants, which is the CH4, the energy of the CH4 plus the energy of the O2. So in this case, we are, to just illustrate more, we are looking at this, and then 2O double bond. So when you go to the bond energies table, you realize that you have 4 of the CH bond, and then you have 2 of the oxygen bond. So this will be 4. The CH is 412 plus 2. The double bond is 490. So when we do the overall math, we'll get 2628 kilojoule per mole. Now this is the enthalpy of reactant, which is bond formation, denoted by a positive 2628 kJ per mole. Then the enthalpy for products, again, to illustrate more, it means that we are looking at the carbon, this, plus 2 of this. So the carbon, we have 2 of these. So there's this bond and there's this bond, meaning there are 2. So it's going to be what's 831. So 831 by 2 plus 2. Then again we have 2 of these, the OH. So we have 2 of them inside, which basically means that we have a 464 plus a 464. So the total gives us a 3518 kilojoule per mole, which is negative, denoted by a negative, as it is representing the bond formation. Therefore, the overall enthalpy is going to be that of reactants plus that of products. So it's going to be positive 2628 kilojoules per mole plus the negative 3518, which gives us a total of negative 80 kilojoule per mole. That's the final answer. Then B2 requires us to calculate the amount of heat that would be produced. So when we look at this reaction, in this reaction we'll realize that 1 mole produced 1 mole of methane, 1 mole of CH4 produced a negative 8, what did we calculate? Negative 890 kilojoule that was produced per mole. That's the amount of energy that was produced. So what if 1,200 cubic centimeters of methane gas was measured at RTP? So there it takes us to more concepts. We know that 1 mole at RTP is equivalent to 24 cubic decimeters. That is at RTP. So what if 1,200 cubic centimeters was measured? So we convert this to cubic decimeters, which is going to be 1.2 cubic decimeters. Then how many number of moles? Therefore 24x is 1.2 moles divided by 24 divided by 24. Therefore x is 0.05 moles. So how much energy will be produced by 0.05 moles? We say x. Therefore x is going to be 0.05 times 890 kJ. So this will give us the energy of 44.5 kilojoules. That's how much energy that can be produced. Then the last question is draw the energy level diagram. So this is an exothermic energy level diagram. So energy this side, that is in kJ per mole. Then we have this, have the head drops like that. So this is where the CO2 and the H2O as your products, and this is where your CH4 and your oxygen is. Then this is going to be your enthalpy change, which is 890. Yeah. So see you in the next video.